Assalamualaikum warahmatullahi wabarakatuh. Okay, today this video will contain three topics: polar form of complex number, Euler form, and de Moivre theorem. So we start with the polar form of complex number. Recall that a complex number is z equals to a plus bi and may be represented by polar coordinate r theta with r more than or equal to 0, and in fact a is equal to r cos theta, b is equal to r sin theta. So you can see how it represented by using the figure 7.2. From figure 7.2 we have z is equal to a plus bi equal to r cos theta plus ir sin theta. Thus, we can write complex number in polar form. Z is equal to r times cos theta plus I sin theta, where r is equal to z modulus equal to square root of a square plus b square, and theta is equal to argument z equals to inverse tangent of b over a. Example 6, you can see the example 6. Find the modulus and argument of z equals to 2 plus 3i. After that, express z in polar form. Okay, so it gives you the complex number 2 plus 3i. So the first step, you have to find the modulus and argument in order to form the polar form. Okay, so these two things you have to find. So first thing first is r is equal to z modulus, and then it equals to 2 square plus 3 square, and then you have to find the square root, this one. Alright, so put in the formula. Okay, this is the r we call z modulus, and we got the answer is square root of 13, and then theta is argument z is equal to inverse tangent of 3 over 2. Okay, 3 is the value of b, and 2 is the value of a, this one. Okay, when we got the r and the theta, we have to substitute into the formula of polar form. Okay, the formula of polar form is r is times cos theta plus I sin theta. Okay, so r is square root of 13 cos, and then the theta is 56.31 plus I sin 56.31. So this is the final answer. Okay, the next example still the same about the polar form, but then we have z is equal to negative 2 plus I. Okay, this is our A, negative 2 is our A, and then the B is 1. Okay, expressed in polar form. So the first thing that we have to find is the z modulus. So negative, the square root of negative 2 square plus 1 square. So we got square root of 5. Then the theta is argument z, then inverse tangent of negative 1 over 2. Okay, so we got negative 26.57. Okay, but the angle is cannot possibly correct because z lies in second quadrant and the angle is represented as acute angle. Okay, the correct angle is this one. So what we got, this one is not the real theta. So theta we need we know that tangent will be negative in second quadrant, and then 180 minus the the first answer. So we got that theta is 153.43. Okay, then after that we form the polar form. So our r is square root 5 and our theta is 153.43 degree. So square root 5 times cos 153.43 plus I sine 153.43. Okay, we can also do multiplication and division complex number in polar form. So to form the multiplication, we have to form the product, multiply the magnitude and add the angles. Okay, magnitude lepas tu add the angles. Okay, consider two complex number in polar form. So the first one is R1 times cos theta 1 plus I sin theta 1. This is the first. And the second one is Z2 R2 times cos theta 2 plus I sin 2. So multiplying them together gives Z1 times Z2. Okay, so it tells you that you have to multiply the magnitude. So this is the magnitude R. So okay, just the first thing that you have to do is just copy the complex number, the first complex number and the second complex number, and then you have to multiply the magnitude together, and then cos theta 1 times cos theta 2 minus sin theta 1 sin theta 2 plus I sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. So this is a bit long, but then we can use the trigonometric identities that tells you that by using trigonometric identities, we know that cos theta 1 plus theta 2 is equal to cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, and sin theta 1 plus theta 2 is equal to sin theta 1 cos theta 2 plus cos theta 1 and sin theta 2. Okay. It is a little bit longer because we expand the bracket and it become like this. But then we can do this by using trigonometric identities. So the first one will be cos theta 1 plus theta 2. Okay, because cos theta, okay, this is the it's meshed together. So sin theta 1 cos theta 2, it will use this formula. Okay, the second one will be sin theta 1 plus theta 2. This one will be cos theta 1 plus theta 2. Ada I lah, ada imaginary number. Okay, so after we simplified, so you have to use this. Okay, it much more simpler. Okay, simpler than this one. Okay, just use this. Okay, the second part is division rule. To form the quotient, divide the magnitude. Okay, so you have to divide the magnitude, subtract the angles. Okay, divide the magnitude and subtract the angle. So consider two complex number in polar form. So this is the first one and this is the second one. So it tells you that you have to this is how it looks when we put it on in quotient form. Okay, the the first complex number and the second complex number. Thus, the simplifying for division is divide by modular I and subtract the argument. Okay. So dia cakap tadi kita kena divide, lepas tu yang argument dia kita subtract. Okay, so Z1 over Z2 is equal to R1 over R2 times cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. Okay, this is the final looks of it. So, we look at the example. It tells you that you have two complex number in polar form. So you have to compute Z1 times Z2 and Z1 over Z2. So the first one, when we have, okay, this is the first complex number, second complex number, both in polar form. So we know that when we want to form the multiplication, we have to multiply the R, okay, the magnitude, and cos 60 plus 30, okay, the second theta, and plus I sin 60 plus, so it will become like this lah. So we know that 60 plus 30 is 90, 60 plus 30 is 90, so you can simplify it. Okay, after that, we want to compute the Z1 over Z2. So the R, we have to divide, so 5 over 4. And then the theta we have to minus. Okay, so it becomes like this. Alright, so the first important things that you have to know is how to convert the complex number into the polar form, and then what do you need when you have to perform the multiplication and division process of complex number in polar form. Okay. Next is Euler form of complex number. Euler form is stated as E, okay, to the power of I theta equals to cos theta plus I sin theta. From complex number, when written in polar form formula, we have this. Okay, this is the polar form. This is the Euler form. Thus, the exponential form, the exponential polar form using Euler form is Z equals to R E I theta. Okay. So when we have a polar form, we can convert it into Euler form, and it calls as exponential polar form using Euler form. Okay. So equals to Z equals to R E to the power of I theta. Okay, simplify the following complex number. So Z equals to E to the power of 1 plus I pi over 2. Okay. We know that A to the power of M plus N is equal to A to the power of M times A to the power of N. Therefore, okay, this one. Okay, this is the Euler form. Okay, it is in Euler form. Yes, it is in Euler form. Okay, and then we know that e to the power of 1 plus I pi over 2 is equal to e to the power of 1 times e to the power of I times pi over 2. So we can, it will be like this. Okay, e to the power of 1 times cos pi over 2 plus I sin pi over 2. And it becomes e to the power e times o e times 0 plus I, and the final answer is IE. Okay, this part is applying the first thing that it tells you that ei theta is equal to cos theta I sin theta. Cos theta I sin theta. Okay, so kat sini lah dia ubah menjadi bentuk seperti ini. So dia dapat dalam bentuk ini. Okay, jadi E kuasa 1 darabkan yang kepunyaan ini. Bentuknya seperti inilah. So cos pi over 2 nilai dia adalah 0. So I sin pi over 2 nilainya adalah I. So kita selesaikan di situ. Okay, yang ini a bit complicated sikit lah. Okay, let z equals to 1 plus I expressed in Euler form. So, when we want to express in Euler form, we know that we have to find R and theta. Okay, R and theta. So we need to find the R or modulus Z dengan theta. Okay, so R is equal to square root of A2 plus B, A square plus B square. So we got the value is square root of 2, and theta is equal to inverse tangent B over A is equal to inverse tangent of 1 over 1 is equal to pi over 4. Okay, so we know that Euler form is, okay, Euler form is Z equals to R E I theta. Z equals to R E theta. So our R is square root of 2. Okay. E to the power of I pi over 4. Simple as that. So we know that when we want to form the Euler form, okay, the requirement still the same like you want to form the polar form. Okay. We need to find the R and theta. So given that Z1 is equal to R1 E to the power of I theta 1 and Z2 is equal to R2 E I to the power of I theta 2, we can obtain formula for product and quotient for complex number. Thus we have, okay. Okay, so if we want to multiply the product, when we use the Euler form, so Z1 times Z2 is equal to R1 e to the power of I theta 1 times R2 e to the power of I theta 2. Okay, we have to multiply the magnitude R, okay, R1 times R2 times e to the power of I theta 1 plus theta 2. Meanwhile, if we want to divide Z1 over Z2 is equal to R1 e to the power of I theta 1 over R2 e to the power of I theta 2 is equal to R1 over R2. Okay. times e to the power of I theta 1 minus theta 2. Okay, so next we want to improve our understanding, so you have to see the example. Let's see that we have z1 and z2. This one is z2. Okay, sorry. You have okay. Z1 is 1 plus I and z2 is 1 plus I to the power of sorry. Z2 is 1 plus I square root of 3. Find z1 times z2 and z1 over z2 in Euler form. So the first thing that we have to find is you have to find r and theta for both complex number. So the first complex number is z1 is equal to 1 plus I. So um, okay, for z1 3 plus okay, so we got that z1 is equal to square root of 2 e to the power of I pi over 4. Okay. Alright, so I think that we have some mistake here because z2 is square root of 3 plus I. So something is not correct here. So you just follow that z2 is equal to square root of 3 plus I. So we got that the r is 2 and the theta is pi over 6. So we got that the z is 2 e to the power of I pi over 6. So we have to put into the formula. Okay, we know that when we want to form the multiplication, we have to multiply the r and e to the power of I theta 1 plus theta 2. So this is the final value. So meanwhile, when we want to form the division, we have to divide the magnitude 1 over magnitude 2 and the theta we need to minus. So e to the power of I pi over 4 minus pi over 6. So we got the final value 0.707 e to the power of I times 1 over 12 pi. Okay, the last part is when you want to form the Moivre theorem. If n is a positive integer, so z to the power of n equals to r to the power of n times cos n theta plus I sin n theta. This result is known as the Moivre theorem. Okay, so we can see that the de Moivre theorem looks like the polar form, but it has n as a positive integer. It has a power form. Okay, so proof. From polar form, we know that z equals to r times cos theta plus I sin theta. So we have r times cos theta plus I sin theta to the power of n. Okay, so when we convert it to Euler form, so we got the re to the power of I theta to the power of n, so equals to r to the power of n e to the power of I n theta. So it is r to the power of n times cos n theta plus I sin theta. Okay, this is the Moivre theorem. Let Z1 equals to R1 times cos theta 1 plus I sin theta 1, and Z2 is equal to R2 times cos theta 2 and I sin theta 2, and multiplying these two complex number, we obtain Z1 times Z2 is equal to R1. Okay. Okay, this part is the multiplication using the polar form. Okay, if theta 1 is equal to theta 2, then it is equal to theta. The above result will give cos theta plus I sin theta square. It will become cos 2 theta plus I sin 2 theta. Then cos theta plus I sin theta cube is equal to cos theta plus I sin theta square times cos theta plus I sin theta. So it will become cos 2 theta plus I sin 2 theta plus cos theta plus I sin 2 theta and become cos 3 theta plus I sin 3 theta. This suggests the general formula of cos theta plus I sin theta to the power of n is equal to cos n theta plus I sin n theta. This one. Okay. Yang panjang-panjang tu tadi, okay. What I try to explain is how we get the final looks of cos theta plus I sin theta to the power of n, and it becomes like this. Okay, so calculate I times I, calculate I plus I square root of 3 to the power of 6 in the form of A plus BI. So you can see the step by step. First step, you have to convert in polar form. So we get the R. I think that this is 1, not I. So we get that the R is equal to 2, and then theta is equal to pi over 3. Okay, this is the first step. And then we convert into the polar form. Second step, find the Z to the power of 6. Okay, so we know that, okay, this is when n to the power of 1, or n is equal to 1. So when it becomes Z to the power of 6, it, okay, 2 cos pi over 3 plus I sin pi over 3 to the power of 6. So the magnitude you have to multiply by 6. Okay. Okay, because we know that the formula is Z to the power of n is equal to R to the power of n. Okay, the formula is Z and R to the power of n. Okay, cos n theta plus I sin theta n theta. I sin n theta. So our n is equal to 6. Okay, so we know that 2 to the power of 6 here, and then cos n theta, so 6 times 6 times 60, it becomes 360. Same like this. Okay, 360. So we got 64. Okay, we can find the value here, and the value here, it becomes 64 plus 1 times 0i. So the final answer is 64. Okay, and it said that let z, okay, we see the next topic is roots of complex number. Let z equals to r times cos theta plus I sin theta, and let n be a positive integer. Then z has the n distinct roots, okay, where k is equal to 0, 1, 2 until n minus 1. Okay, find all roots of z to the power of 3 is equal to 1 plus I to the power of I square root of 3. Okay, so the first thing first that you have to find R, okay, modulus z, the argument of z. So we got this and this. So the first step here, here. So put it in polar form. Okay, so it becomes 2 cos 60 plus I sin 60. Okay, by applying formula of roots of complex number with n equals to 3, okay, so become like this. Okay, from n to the power n equals to 3, setting from k 0, 1 and 2, we obtain 3 roots. Okay, okay, saya nak ulang balik yang tadi pasal roots of complex number. Okay, kita ada z equals to r cos times cos theta plus I sin theta, and let n be a positive integer that z has n distinct roots. Okay, okay, it gives you z zk is equal to r over 1 over n. Okay, it should be like this. Okay, I want to, dekat sini saya nak tukar sikit, z1 over n is equal to r1 over n, okay, times cos times theta plus 2k pi over n, and then I sin theta 2k pi over n. Okay, what is k? K is starting from 0, 1, 2 until n minus 1. Okay, example 13 shows you that it asks you to find all roots of z cube equals to 1 plus I square root of 3. It means that it has n equals to 3. So it has 3 roots. Okay, and then the first step, I told you before that you have to find the modulus of z, argument of z, and then put it in polar form. Okay, after that, when you got in polar form, okay, you have to apply the formula of roots of complex number, okay, with n equals to 3 here. Okay, just masukkan dalam formula tadi sebab formula dia adalah okay, R kita adalah 2. So 1 over N, okay, R to the power of 1 over N. So N kita adalah 3. Okay, di mana awak apabila awak nampak N, awak tukarkan lah mana. Okay, times cos 60 plus 2 K pi over 3. Okay, formula dia memang over okay, kalau N tu kat sini masih ada N, so N kita tadi adalah 3. Theta kita tadi ialah theta yang kita dapat adalah 60. So masukkan, ini adalah general formulanya. Okay, bila kita nak cari satu-satu kita punya roots, okay, jadi K kita bermula daripada 0, 1, 2. Okay, ini bukan Z, awak perlu betulkan sini adalah K0, K1 dan K2. Okay, so roots kita yang pertama bentuknya adalah seperti ini. Okay, apabila K sama dengan 0, dia masukkanlah, okay, K ni kat sini 0. So dia akan jadi 2 cos 1/3 darab cos 20 tambah I sin 20. Okay, lepas tu K dia cos 1 dia jadi cos 60 tambah 2 pi. Okay, kalau 1 kan kat sini, betul tak? 2 darab 1, 2 darab dengan pi, so 2 pi per 3 darab dengan I sin 60 darab 60 tambah 2 pi per 3. So dapat macam ni. Okay, and then bila K kuasa K2 dia jadi 2 kuasa 1/3 darab dengan cos 60 tambah 2 darab 2 darab dengan pi per 3 tambah I sin 60 tambah 2 darab 2 pi per 3. So ini jawapan dia. Selalunya kita akan tulis macam ni. Okay, K0 so sama dengan Z1 sama dengan ini. Okay, kat sini dia macam ada missing sikit lah. Dia boleh mengelirukan awak. So K1 sama dengan Z2 sama dengan ini. K2 sama dengan Z3 sama dengan ini. Okay, kalau awak tengok kenapa K kurang, sebab dah diberitahu kat sini K mestilah N tolak 1. Dia mesti bermula daripada 0. Maksudnya kat sini bila kita punya roots kita 3, so K kita yang kita perlu masukkan adalah nilai 0, 1 dan 2. Kalau K kita kalau roots kita 4, so yang kita kena masukkan adalah 0, 1, 2, 3. Kita mesti bermula daripada 0 untuk K. Tetapi N mestilah 3 lah. N kita mesti 3. Kalau kita punya roots kita 3. Kalau roots kita 4, kita masukkan N kita bersamaan 4. So depends pada soalan. Yang pastinya apabila awak nak buat yang nak cari roots of complex number ni, awak kena tahu macam mana nak apply yang polar form dulu yang mula-mula. Okay, sebab kita perlu cari dia punya Z modulus, argument of Z, and then masukkan dalam polar form, and then baru kita masukkan dalam formula of roots of complex number. And then baru macam mana nak cari roots tu pula, nak cari nilai roots, baru kita masukkan nilai N dan juga K tadi. Okay. So itulah ketiga-tiga bentuk complex number yang awak perlu tahu, iaitu saya ulang sekali lagi, polar form, Euler form dan Moivre theorem. Okay, basically ketiga-tiga cara ni menggunakan asas daripada polar form sendiri. Okay, daripada polar form baru kita boleh gunakan Euler form, and then daripada polar form juga kita boleh construct menggunakan Moivre theorem tadi. Okay, so itu saja untuk kita punya video kali ini. Saya harap apa-apa masalah nanti kita boleh bincang dalam next class. Okay, thank you.